this what is dynamic in relation one by one. We'll try to understand.
Yeah.
See, what is dynamic?
Hmm.
What is dynamic?
Yeah.
No, dynamic equilibrium. Dynamic equilibrium means that molecules
Hmm.
or ions of reactant and product are continuously changing, continuously reacting and interconverting.
Yeah.
So that is the meaning of dynamic. In dynamic equilibrium, molecules or ions of reactant and products are continuously reacting and interconverting in each other.
Hmm.
If I give you the example like this way, CH3, COH, this give you something like this: CH3,
Hmm.
COO minus plus H plus. Is it ionic equilibrium or chemical equilibrium?
That will be ionic because there's
This
ions in it.
fantastic. This is ionic equilibrium,
Hmm.
and your chemical equilibrium is this one. So here, the reactant and products are continuously reacting. Now this reactant is reacting, and the product is also getting reacted, and they are
Yeah.
interconverting each other continuously. It is a happening process. It never
Hmm.
stops till the equilibrium is disturbed. So this
Yeah.
is the meaning of your dynamic.
Hmm.
Now the second thing is the forward and the backward reaction occurs at the same time.
Yeah.
Forward and a backward reaction occur at the same rate. So the amount
Hmm.
of time taken for reactant to get converted into the product, same will be the time taken by reactant to get converted into the product.
Good.
So that is called as a ROF, rate of forward reaction is same as the rate of
Back.
backward reaction. So I hope you got it. What is the rate of
Hmm.
forward and rate of, I'm just trying to explain the same thing which I had already given you the beginning. So the next, what is the meaning of concentration of reactant and product remains constant? What does it
Hmm.
mean? The third characteristic. What is the meaning of
So, it, uh,
concentration of reactant and product and the product remains constant at equilibrium. So what it means? It
hmm.
like the rate of forward reaction is same as the rate of backward reaction, as I told you.
Yeah.
Everything is like connected with each other here. There's nothing like
Hmm.
any separate concept is going to arrive for this. As we
Yeah.
know that rate of forward reaction is same as the rate of backward reaction at equilibrium, at a
Equilibrium.
equilibrium. So what happens here, as you know, equilibrium
Hmm.
can be approached. Now what is the meaning of this concept? I will tell you.
Hmm.
Approached from any side of reaction, from any side. It's like on the reactant side or the product side, on the right hand side or the left hand side, we can approach the equilibrium.
Hmm.
Example is like here, H2 plus I2 give you two molecule of HI. Here all are gas. This is also
Hmm.
gas. This is also
Hmm.
gas.
Okay. Okay.
HI is also gas.
Hmm.
So if I give you the graph,
Hmm.
so on the y-axis we have a concentration. This is a
Hmm.
concentration of reactant,
Hmm.
and here we have a time. Here we have a time. Now you tell me, as the time will increase, concentration of reactant will decrease or increase?
Well, concentration of reactant will decrease.
This is the reactant. Is it going to decrease
Decrease.
or increase?
It will decrease, but
Fantastic. It will
yeah.
decrease. Yeah. See, if you, because at the beginning, the concentration at the beginning
Hmm.
at time equals to zero. Whose
Yeah.
concentration is maximum?
Hmm.
Concentration of reactant is maximum,
Yeah.
and concentration of product is
Lower.
zero.
It's zero.
Zero, because it has not started at all reaction.
Hmm.
So when the time was here zero, this is zero, this is like a one, this is like a two, three, four, five. This is in the minute.
Yeah.
Okay, I'm just putting the number here. Concentration
Yeah.
is like I can say here it is like a two, or I can have here 4 mole
Hmm.
per dm cube, 6,
Yeah.
8, 10 mole per dm cube. So initially the concentration is going to be minimum for product, and the
Okay.
concentration of reactant is maximum. Okay, so we'll
Hmm.
start from here. I will start. I'm going to start from here, and this
Yeah.
is like a falling, falling, falling. A time comes, it becomes parallel to the y-axis.
Okay.
You can see the graph. So
Hmm.
initially the concentration, is it this the graph which is decreasing, is it for reactant or product?
Yeah, for product. I mean,
This is for
reactant.
reactant, because the
Yeah.
concentration is decreases as the time is increasing. So now you
Hmm.
tell me, at the beginning whose concentration is going to be nearly zero?
The
Product.
beginning, product.
So as the time increases, the concentration of product also increases.
Yeah. 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 True.
So there is an increase in concentration of product,
Hmm.
and there is a, this is a decrease
Yeah.
in concentration of reactant. So from this graph, I can say that, so whatever is, there is a decrease in the reactant,
Hmm.
you are able to see there is a increase in the concentration of reactant.
Yeah.
As the time is increasing, there is a decrease and there is an increase, both are happening simultaneously. And if the reaction is like a reversible, so I can get back to the reactant also, because if you decrease the time,
Hmm.
you will find there is a more amount of reactant and less amount of
Product.
product. So this is
Yeah.
with the help of graph we are able to explain on what how the concentration of reactant and product is like keep on changing. Did you understood all this thing?
Yes.
Okay, are you writing or taking the screenshot?
Yeah. I wrote it all down.
Okay, okay. So you just write it, then I will move ahead.
Yeah, it's done. Sir.
Is it done?
Yeah. Yeah.
Okay. So now we'll talk about the equilibrium need closed system. Why the closed system? I have already explained you. This I will revise it. Do you think if the container is open, is it going to be forward reaction or backward reaction or both? Container is
It's
open.
oh, it's open. It will only be forward reaction because there's loss of the product, so you can't really reverse the reaction.
Yes, if both the reactant and product are gas, then there is
Yeah.
a problem. If both are solid, then there is a no problem.
Hmm.
So mainly there is a gas gets released mainly. So we always carry out the reaction in closed container only. So equilibrium
Yeah.
need closed system.
Yes.
We have already discussed this. So forward and the backward reaction is only possible in closed system.
Hmm.
Agree?
Yeah.
Forward and the backward
Hmm.
reaction is possible only in closed system. Only in a closed system.
System.
Now, if you carry out the reaction, if reaction is
Hmm.
carried out in open system,
Hmm.
so what is going to happen?
If reaction is carried out in open system, backward reaction won't occur, so equilibrium is not approached.
Then why it is not going to maintain the equilibrium? Because there is a
Loss.
loss of matter.
Yes.
Then loss of matter to surrounding
Yeah.
may happen. So that's why we always take a closed system.
Hmm.
Okay. Example I can give you here, like a calcium carbonate. If you just heat it and
Hmm.
you get it calcium oxide, that is a solid, and then you get something like a CO2 gas. If the same
Hmm.
reaction is carried out in an open container, you will find there is a evolution of the CO2 gas in atmosphere. So
Hmm.
there is only calcium oxide left, so which is not going to make a equal impact like a calcium carbonate does.
Yeah.
So there is a loss of equilibrium. There is a loss of equilibrium in open system. Open system. Now, now we'll talk about very important concept of this particular chapter. If you change your equilibrium, what is going to
Hmm.
happen?
What will
Changing the
change?
position of equilibrium. This is very important.
Then you will have more products than reactants or more reactants than products.
Yes, we can have more products is like number of gases you're asking.
Hmm.
Here,
It will have,
if you see any particular reaction where you will have a, like if I ask you this reaction, like two molecule of SO2 plus one molecule of oxygen, this
hmm.
give you three molecule of two molecule of SO3. Now this is gas, this is also gas, and this is also gas. Now
Yeah.
the number of gas molecule, how much here? It is total.
Number of gas molecule,
Total how much?
uh, 5.
2 plus 1 plus 2, that is 5. But
5.
the number of gaseous molecules are more on the
The more on the reactant side.
reactant side and less on the product side.
Yeah.
Okay, so there is nothing like that. Reactant will be less or product will be more. It is nothing like that. Basically, this reaction is a decomposition. This is a
Decomposition.
decomposition. You're breaking the bigger molecule into the smaller molecule. Now, when you
Yeah.
add a two three molecules together,
Hmm.
so they will get added up, and then you will get a lesser number of molecules.
Yes.
So now moving ahead, we'll talk about the changing the position of equilibrium. This is very important concept.
Yeah.
Changing the position of equilibrium.
Hmm.
Now, what is going to happen? Now, the position of equilibrium is like a amount of, what is the meaning of position? The position of
Hmm.
equilibrium uh, refer to refers to the relative amount of to the relative amount of
Hmm.
product and the reactant
Yes.
product and the reactant present in equilibrium mixture present in an equilibrium mixture. Now if the
Hmm.
system is in equilibrium and we have a disturbance in the temperature, we have a disturbance in the temperature, so what is going to happen? See, if we have a if system
Yeah.
is in equilibrium and I change its parameter, like I change its temperature, or I can change its concentration, or I can change its pressure. So anything I
Yeah.
can change here. So if I'm doing the some amount of change modification, so what
Hmm.
the reaction is going to respond, how it is going to respond, that we need to check it. So reaction try to nullify that effect what we are trying to make a changes. So if the system is in equilibrium and I change its temperature, concentration and the pressure, then
Hmm.
reaction try to shift in that direction where change is nullified, where the change is nullified.
Hmm.
Okay, if the system is in equilibrium and I have changed its temperature, pressure, any parameter I can change. If this is happening, then reaction will, but obvious it will lose its equilibrium. So
Yeah.
again, it will come back to the equilibrium position. So how it is able to get it back? Is it going to forward or it is going to backward? This is very interesting and important. I will give you the one example. Now
Yeah.
see, very simple example like your combustion CH4
Hmm.
plus O2 give you CO2 plus water
Yeah.
plus energy, that is heat. Heat is given
Yeah.
out. So methane, oxygen. Now what I'm trying to do here, if I heat this reaction, if I heat, so what is going to happen? Is it going to go forward or it is going to get backward? Is it after heating, is it like a
Yeah.
forward
Forward.
or backward? We just need to check it. So why it will go forward and how it will go forward, so we'll see one by one. So there is a very important principle. You must have heard the name of that principle. There is a Lee
Hmm.
Chatelier principle. Have you heard it? Lee
No.
Chatelier principle. Now see that this is the cream concept of this chapter.
Yeah.
There is a Lee Chatelier principle. Now what it says that, it
Hmm.
says that if one or more factors, if one or more factors
Hmm.
that affect an
Okay.
equilibrium is changed,
Yeah.
then the position
Hmm.
of equilibrium shift in that direction, which reduces, or I can say that opposes the change, opposes the change, or you can find which can nullify the effect.
Didn't understand the end part.
So this is the actually Lee Chatelier principle.
I
If
didn't
they are,
understand the last part.
they can ask you separately, write a note on the Lee Chatelier principle. Then you have to write it. If a reaction was in equilibrium, I have changed its parameter like temperature, pressure, whatever I can change here. The reaction will try to adjust. It is just like that. I'm standing anywhere and somebody is giving you the jerk. So the fellow give me the force. I will try to that nullify that force. I will adjust either right, left, or up, forward, backward. So the same thing
Yeah.
is going to happen with the reaction. So the first thing I'm talking about the concentration.
Mm.
How does change in concentration affect the position of equilibrium? Now see, basic example like N2 plus 3 molecule of H2 give you 2 molecule of ammonia.
Yeah.
If you look
Yeah.
at the reactant, now here reactant is a nitrogen gas and a hydrogen gas.
Mm.
Product is here ammonia gas.
Yeah.
Now see, the thing which is getting consumed, the thing which is
Yeah.
getting consumed is
Yeah.
here nitrogen and hydrogen is getting consumed.
Mm.
Now the thing which gets consumed, if you increase that amount, if you increase that
Yeah.
amount, reaction is going to get forward. Now if
Yeah.
you have increased here in this particular reaction, if you have added more amount of nitrogen gas, so the
Mm.
amount of nitrogen got more here.
Correct.
So
Yeah.
once the amount of nitrogen got more here, so equilibrium is disturbed. So now what
Mm.
the nitrogen will do, nitrogen will react with the hydrogen, and whatever the extra nitrogen you have added, that will get
Mm.
converted into the ammonia.
Of ammonia.
In the same manner, if I add more amount of hydrogen, so the more amount of hydrogen will react with the nitrogen and you will get a ammonia.
Yeah.
So the thing which is present on the reactant, if you increase, if I increase, reaction goes forward.
Yeah.
Reaction goes forward. Now if you tell me if I decrease, logically, if I decrease
Mm.
the nitrogen gas, so amount of nitrogen will be less.
Yeah.
So reaction will I should get back nitrogen which I have lost. So what it will
Mm.
do, it will get it from the ammonia only. Ammonia will undergo dissociation and it will give you the whatever the lost nitrogen is there, it will get recovered.
Huh.
So when you have increased the reactant concentration, it goes forward. When you decrease the reactant concentration, it goes
Backward.
backward. I hope you got it.
Yeah.
Now we'll talk about the product. Now see, if there is a two case, if
Mm.
ammonia is added in this reaction,
Wait. I have a question though.
ammonia is added, is it going to backward or forward?
If ammonia is added, it go backwards. Yeah.
Fantastic, it's a backward
Yeah.
because the concentration of ammonia is more here. If
Yeah.
ammonia is removed, if ammonia is removed from this reaction, then removed or decreased, we can say anything.
Mm.
So reaction will be forward, yes or no?
Yeah.
Because the concentration of ammonia got decreased, so reaction will for the whatever the loss is happening, I should get it back. So it will start
Yeah.
converting ammonia,
Mm.
nitrogen and hydrogen to ammonia. So it is a forward.
Yeah.
So I hope you got the what is the effect of concentration. Concentration is increasing, decreasing. So according to the reaction either try to go forward or backward.
Yeah.
Is it clear?
Uh, I have one question though. Like
Yes,
for
yes,
every reaction, is the equilibrium different?
yes,
So like 60% concentration of product, 60%,
yes, yes,
40%. Okay.
yes, yes. There is a never ever this your 100% of conversion at the beginning only I told you,
Yeah. Yeah.
and at equilibrium also.
Hmm.
At equilibrium also it does not mean whatever the this your amount of nitrogen is there, the same amount of this your hydrogen will be there, or the same amount of ammonia will be there. Their concentration may vary, and it does.
Can.
The concentration is not going to be the same. If I say the concentration of nitrogen is 8 mole per
Hmm.
dm cube, so the same is not going to happen with ammonia. Ammonia will have a different concentration.
Okay.
So concentration, whatever the concentration you got it during the reaction, now you have a standard reaction. You do modification in standard reaction. Are you getting? So in a standard reaction, once the reaction is in equilibrium, now you do the changes.
Yeah.
Now moving ahead, I will give you here. I will give you one example. Then I
Hmm.
will go forward. Very simple example. Have you heard something called the ester?
Yeah. Yeah. Esters. Yes.
Esters are an organic compounds,
Yeah.
and the ester is obtained after reacting with an acid plus alcohol. When acid and the alcohol gets reacted, you get a ester. So I will
Hmm.
give you the same example here. I have got it here. Acetic acid, that is CH3COOH, that is in the form of liquid, and you got another alcohol like C2H5OH, ethyl alcohol.
Hmm.
This is also in the liquid. So as I told you, acid and alcohol always react together and give you the sweet, pleasant smell of an ester. So here the acid part will lose the OH, and sorry, acid part will lose OH, and the alcohol part will lose the H, and there is a
Hmm.
loss of water. OH is from an acid and the H is from here, and these two will get
Yeah.
added, and we are going to get a like this CH3 C double
Good.
bond O bond. Your
Okay.
this is uh, C2H5
Yeah.
C2H5. This is called as ethyl acetate, ethyl acetate or ethyl ethanoate. Ethyl ethanoate is the IUPAC. So now here, if I increase the concentration of acetic acid, what is going to happen? Can you tell me? Is it forward or backward?
Forward reaction.
If I remove the water, is it forward or backward?
We go back. We go forward.
If I add ethyl acetate,
Oh, if you add ethyl acetate, we go backward.
fantastic. So you got the concept. Fine. Okay.
Hmm.
So if you like whatever the thing is present on the reactant, I give the this way.
Hmm.
Uh, Reactant side is like needed stuff. If you decrease the needed stuff, if you decrease that, the fellow is like, no, no, I don't want that, because that is a needed thing. So reaction will go in the backward direction.
Hmm.
So logically I give this explanation. The thing which is present on the reactant side, it is a needed stuff,
Yeah.
and the thing which is present on the product side, it is unwanted stuff, because they react together and they give you the unwanted thing which we don't want. So this is the unwanted.
Right.
So if you remove unwanted thing, you are more favorable.
Correct.
So reaction is forward. If you add
Okay.
unwanted, I'm not comfortable, reaction will go backward.
Okay.
So it is
Yeah.
like this way I explain needed and the your unwanted thing.
Uh,
Now we'll talk about the temperature. That's very important. How does the temperature plays a very important role for this? What is enthalpy? Can you define enthalpy?
um, Change in the heat content.
Enthalpy is the heat content of the system.
Yeah.
Heat,
Oh, yeah, not enthalpy change is heat change.
heat content of the system. So whatever is the amount of heat present in a system, so that is called as an enthalpy.
Hmm.
So it is denoted by an alphabet called as delta H, that is a change in enthalpy. So change in
Hmm.
enthalpy can be positive or it can be
Negative.
negative. So if it is a positive, we call it as an endothermic reaction.
Yeah. Negative is exo.
Exothermic, fantastic. Now heat is released in exothermic.
Yep.
Now here heat is absorbed, heat is absorbed. Now, so how does the temperature plays a very important role for any kind of reaction? So we'll
Hmm.
see with the help of a particular example. Let us see the decomposition of, let's see, decomposition of hydrogen iodide.
Yeah.
It's like we got a two molecule of HI, it undergo dissociation and it give you H2 plus I2, and
Hmm.
here enthalpy is plus 9.6 kilojoule per mole. So by looking at the value of delta H, can you tell me is it endo or exo?
This will be an endothermic reaction.
Endothermic, fantastic. And one more thing, breaking is always endo and making is exo.
Hmm.
Breaking, if you want to break anything, you have to give energy.
Yeah.
Breaking is an
Hmm.
endo
Yes.
and making is an exo.
Yeah.
Fantastic. So I have here a few temperature list.
Hmm.
I have given you the temperature here and then concentration, uh, concentration of your HI at equilibrium.
Yeah.
Similarly, the concentration of your H2 and I2 at equilibrium. Now the temperature is here like 25 degree. I will start from the 25 degrees. There is room temperature,
Yeah.
25 degrees Celsius. And then I have 230. That's very high temperature. You can have a 430 or 425 will also do
Hmm.
430, and then we can have a 500 Kelvin, approximately 500. So as the temperature is, I'm talking about only this particular reaction. I'm not talking about the overall because it
Hmm.
varies from reaction to reaction, because I already have given the reaction is exo or endo depending upon the reaction is going to vary. So
Yeah.
when the concentration of HI was noted at the 25 degrees Celsius, the HI is present on the reactant side. Its concentration comes like 0.934 mole per dm cube. So
Yeah.
again, when the temperature is increased, it is like less 0.86. When you heat more, the temperature gets further, your concentration gets further lowered, 7.8, that is lesser than 0.86. And you heat it again, the temperature, then you find it is very, very less, now 0.77.
Yeah. Yeah.
So as the concentration of HI is decreasing, there is an increase in the concentration of HI and iodine.
Yeah.
So logically, the concentration of H2 and I2 is increasing. So it
Yeah.
was initially like 0.033 mole per dm cube at 25 degrees Celsius. You
Yeah.
heat it, logically it will be more because it is endothermic. It's like a 0.68. You again heat it it's like a 0.10. Again you heat at 500 Celsius, you find the temperature is this much, and then the amount is like 0.11 mole per dm
Yeah.
cube.
Correct.
So heat is playing a vital role when the temperature is increasing or decreasing, because your reaction is playing vital role. If the
Hmm.
reaction is endothermic is like that fellow needs energy, or it is like no, no, I don't want heat. What do you think? When the reaction
It,
is endo, the fellow is like a willing for heat, or it is like no, no, I don't want heat.
it wants heat because it will
Yes,
become faster going forward.
yes, it wants heat. So as you increase the heat, you are able to see the concentration of product is increasing.
Yeah.
If the same reaction would have exothermic,
Hmm.
like combustion, always combustion is the exothermic in the nature. So just let me scroll up. If I ask you this reaction, can you balance this particular reaction? See here. Um, this is a, what is the name of this compound?
Uh, Organic compound, carbon, cyclic structure, or cyclohexane.
This is cyclohexane. Now, what is this?
No idea. Haven't seen this before.
Have you heard this? Benzene.
Oh, yes, I've heard of it.
This is benzene, and the formula
Yes.
for benzene is C6H6.
Hmm.
Okay, and very important thing, Michael Faraday did its discovery. They are never going to ask all these things, but we
Hmm.
should. Now, Michael Faraday is the great scientist of physics. He did the discovery
Hmm.
of benzene. Now, if you do the
Oh, yeah.
combustion of benzene, now can you give me the product? I have already told you how to balance this reaction.
Hmm.
Just try
Oh,
and
okay.
give me the amount
Six,
of.
6 CO2 plus 3 H2O, then 15 over 2 O2.
Fantastic. 15 by 2, that's your 7.5. And this is how much? 12 plus 3. Fantastic. So, is it exo or endo?
This reaction is endothermic.
This is exothermic. Fantastic. Because this is a combustion. This is a
Hmm.
combustion.
Combustion.
Now, for the combustion reaction, always if you increase the heat, that fellow
Yeah.
don't want heat because that fellow is already giving you heat
Yeah.
because the heat is the part of product. So if you heat that particular reaction will go backward.
Yeah.
Will be backward when it is heated.
Hmm.
So exothermic and endothermic both have a different role. When you heat it, is it goes forward. It depends. Reaction is exothermic or endothermic. When you cool it, it's like forward or backward. Then also it depends upon your temperature. I hope you got the concept of temperature.
Yeah. Yeah.
No,
So
there's a
for
one more.
temperature, does it only increase the forward rate of reaction or it can increase backward also?
When we heat it,
Increase the temperature.
the reaction is going to at the same rate. Right now, we are trying to discuss is it going forward or backward.
Yeah. Oh, I mean,
So
like, can it also go backwards?
it it can go forward or backward. Your question is
Oh.
it will go with the same rate or something like that. You asked me something like that.
Yeah, yeah, yeah.
No, when you talk about the rate, so rate will be the same as it was going backward.
Yeah.
Are you waiting? Because see, if I have this reaction
Yeah.
N2 plus 3H2,
Hmm.
I will get it here 2 molecule of ammonia. See,
Hmm.
if you have added nitrogen.
Yes.
So basically, what was the initial concentration of hydrogen? Because you are not adding hydrogen.
Hmm.
Reaction you started, you had a nitrogen and the hydrogen at the beginning, they were in the equilibrium. Now you have added extra nitrogen. So
Hmm.
technically, the amount of hydrogen will decrease because you have not added extra, because you have added extra nitrogen. So that extra nitrogen needs an extra hydrogen for reaction because the amount
Yes.
of hydrogen was already fixed. So
Hmm.
technically it decreases, but we don't consider. If you read the reference book and all, they don't consider, but they will tell you this. Ideally, there is a decrease in the concentration of other reactant,
Okay.
and it will go with the same rate. There is a no decrease in the your rate of reaction when it is trying to adjust Next is a catalyst.
Huh.
So what is a catalyst? Can you define?
Something that speeds up the rate of reaction by lowering the activation.
Fantastic. The activation energy gets lowered.
Yeah.
Gets Now, what do you say about its forward reaction rate and the backward reaction rate? It is not going
It's
to
possible to go
change.
forward.
It it does not have any effect on equilibrium. The catalyst do not change the equilibrium. Only the catalyst increases the rate of forward reaction or backward reaction.
Okay.
Increases the rate of reaction. And catalyst is of two types. That is a positive catalyst and the negative catalyst. Positive catalyst is like a promoter
Hmm.
which initiate the reaction speed, and negative
Yeah.
catalyst is that one which stops.
Hmm.
You have you heard the chloroform?
Yeah.
In the ancient time, it was given as the anesthesia.
Oh. Hmm.
Chloroform, not in the modern days. It is not given because it is like a
Yeah.
poison. In the lab, you can find the chloroform. You can find the chloroform, but what happens? When the chloroform is kept in an open bottle,
Yeah. Correct.
so O1, yes, it gets evaporated. At the same time, it gets oxidized also
Oh.
because air is having oxygen plus heat
Hmm.
is coming from sun, so it gets oxidized. So when the
Yeah.
chloroform gets oxidized, it gets converted into a poison called as a phosgene.
Oh.
So doctor was not aware is it a chloroform or the phosgene. He has given as an anesthesia, but the phosgene gas is a poisonous gas. If it is given in overdose,
Yeah. Kill the
so there is a
person.
very high risk for the patient.
Ah. Okay.
So I just want to say, if you do not want this to happen, so what I do, I take a chloroform bottle and I add here a very small amount of alcohol, very
Hmm.
small amount of ethyl alcohol. So
Okay.
what ethyl alcohol does? Ethyl alcohol is not letting the chloroform to get oxidized into the phosgene. It does not let. So here the
Oh.
function of ethyl alcohol is act as a
A catalyst
negative catalyst.
or negative inhibitor.
So the one which promotes a reaction is called as the your this positive catalyst, and the one which stops the reaction is called as a negative.